Hey guys, Chapter 9 is about how we can use our data to test a claim. So, this first introductory activity is going to just kind of make sure you sort of see the overview of where we're going in Chapter 9. So, the claim we're going to investigate today is, am I a good free throw shooter? So, I am going to start by claiming that I am an 80% free throw shooter. So to prove this, I shot 50 free throws and I made 32 out of the 50 free throws. Am I exaggerating my free throw abilities? So let's just do some review. The population in this problem is all of the free throws shot by me. The parameter is P, the true proportion of free throws that I would actually make. Your sample here would be the 50 free throws that I shot, and your statistic is P hat, 30 out of 52, so 64%. So on the surface, it appears that I may be exaggerating because I'm claiming that I'm an 80% free throw shooter, but I did 50 free throws and only made 64%. So there are two possible explanations for this. What do you think they are? All right, so one possible explanation is that I really am an 80% free throw shooter, but I had an off day. What's the other explanation? That I'm a big fat liar. So one of these two things is absolutely true. In statistics, these are what's called our hypotheses. We're going to have what's called a null hypothesis, which is going to be symbolized H sub 0. And our null hypothesis is saying that the true proportion is really and truly 80%. And your alternative is I'm lying. So the true proportion is not 80%. So we will be testing any kind of claim by assuming that the person is telling the truth against the alternative that they're not telling the truth. So to test this claim, we are going to assume the first thing to be true. We're going to always assume the null hypothesis is true, that I really am an 80% free throw shooter. And let's examine the likelihood that I'm going to actually make 32 out of 50 shots. And we're going to go back to a topic from Chapter 5. We're going to look at simulation. So I have found a spinner online that I set up 1 through 10. And if you remember, our simulation has to model the scenario that we're representing, 80%. So I'm going to let the numbers 1 through 8 mean that I made the shot. And if the spinner lands on 9 or 10, that means that I have missed the shot. So we're going to spin this spinner 50 times. So I've done this once already. This top row is the number on the spinner, and this bottom row is the number of times that it landed on that number. So if 1 through 8 are the free throws that I made, if we add up all these numbers right here, we should get 38. Or you can take the 5 and the 7 and subtract those from 50 because, lazy. 38 over 50. So the first execution of my simulation said that I made 76%. Well, I say I made it. I don't know if I made it or not because this is assuming I'm telling the truth. And I don't really know right now if I'm telling the truth. So let's do it again for 50 spins. So again, I am taking the easy way out. There were 10 spins that did not go in. So 40 out of 50 is 80%. So if we had been together, we would have all done that, and you would have had a lot of dots. But I did this online spinner that I showed you, and I found these dots, and I have plotted them as we got them. Now, I am going to do one spin to show you how you would have done it if this was you. I have set it to spin 50 times, and it is documenting each and every spin. And I can see down here at the bottom, 4 and 4, there are 8 times the shooter missed. So 8 times that they missed, so that means it's 42 times that they made the shot, which is 0.84. So I am going to put 0.84, put a dot right there. Let me get my bigger dot. 0.84 goes right there. Okay, so as you will remember, I hope, that this is a very approximate sampling distribution of the proportion of times, or the proportion of free throws that were made out of a sample of 50. All right, what does each dot represent? The number of free throws made from a sample of 50. But remember, we are assuming that this is shot by an 80% free throw shooter. Now, I've kind of already addressed this next one. One student says each dot represents the proportion of free throws made out of 50 free throws shot by Miss Snipes. Is this correct? No, because we are investigating if I'm telling the truth. We don't know for sure that I'm an 80% free throw shooter. So we based our simulation on someone being an 80% free throw shooter. I just don't know if it's me or not right now. So I'm going to pause for a minute, and I want you to find the percentage of dots representing 64% or less. So I'm going to come up here, and I'm going to put a dot on 64. So if you want to pause the video so you can count those dots and find the percentage of dots that are 64% or less. Okay, so hopefully you noticed that there was one dot that was 64% or less out of 21 total dots. So 1 divided by 21 is 0.0476. All right, so let me kind of tell you what that means. This means that I am an 80% free throw shooter. If I am, assuming there is a 0.4, well, it says, let me go back. There is a 4.8% probability of getting a sample proportion of 0.64 or less purely by chance. Okay, so in this chapter, this number, this has a name, and we've been finding this number for many chapters now, but now I'm going to tell you the name. This is what is called our p-value. P, I'm assuming, is for probability or percent. So there is a 4.8% chance that you would get, if I was telling the truth, there's only a 4.8% chance that I would have gotten 64% if I'm telling the truth. So what does that mean about my claim? So, do we have convincing evidence that I am exaggerating? Or is it plausible that an 80% shooter could have a performance this poor by chance alone? Take just a second and see if you can think of that answer. Okay. Think of statistically significant. Is this result statistically significant? And the answer is no. So, because there is only a 4.8 chance of seeing this result, or a result more extreme, since this result is less than 5%, we do have convincing evidence that Miss Snipes is not an 80% shooter. All right, so remember, less than 5% is statistically significant. And as a quick refresher, this means that it is not likely to see my result by chance alone. So something must be happening, because that is the result that was seen. What's happening? well, chances are I'm a little bit fibbing about my free throw capabilities. No, I'm a lot fibbing.